This is where we were last time. We looked generally at differentiating a function of a function. So we say here that the derivative of a function is equal to the derivative of one function, the inside function, multiplied by the derivative of the outside function. Now, let us look at an example of that. Suppose we say that y is equal to, say, x squared plus 1 and all of that cube. Now, or, well, let it remain x squared plus 1 cube. The x squared plus 1 is the inside function and something cube is the outside function. Now, let u be equal to the inside function x squared plus 1. Then du by dx is equal to 2x. Alright? And then we have y is equal to, since this is u, we say y is equal to u cube. So dy by du is equal to 3u squared, which is really 3 times x squared plus 1 squared. Alright? Now, dy by dx is equal to dy by du times du by dx. What is dy by du? We have it here. Dy by du is 3x squared plus 1 squared times du by dx is 2x. So du by dx is 2x. Multiplying out, or looking at the pattern here, if we differentiate x squared plus 1, we get 2x, right? And we have the 2x right here. Multiply it by, now, if we differentiate all of this cube, we get 3 times its squared, which is 3 times the very function here squared. So you see that it does work. Now, you can write this as, if we multiply 326x times x squared plus 1 squared. Alright? So that's what we have. Now, you may say, are you really sure? Alright, let's test it out. Our dy by dx is equal to 6x times x squared plus 1 times x squared plus 1, which is x squared plus 1 squared, right? Let's multiply them out. 6x times x squared gives us 6x cubed, plus 6x times 1 gives us 6x, plus, no, it's not plus yet. We're going to multiply this now by the x squared plus 1. So we have x squared plus 1. When we multiply these, we get 6x cubed times x squared, which is 6x to the 5, plus 6x cubed times 1, which is 6x cubed, Then we have 6x times x squared is going to be plus 6x cubed plus 6x times 1 is going to be 6x. So all of this amount to 6x to the 5 plus 6x plus 6x is 12x. 12x cubed plus 6x. Alright? That's what we see. Now, suppose we consider multiplying out the x squared plus 1 cube and then differentiating it. This would be x squared plus 1 times x squared plus 1 times x squared plus 1. Alright? So here, what we would have is x squared times x squared gives us x to the 4th plus x squared times 1, which is x squared, plus x squared times 1. Another x squared gives us 2x squared, plus 1 times 1 gives us 1. So plus 1, and we multiply by x squared plus 1, right? Then after that, we say x to the 4th times x squared gives us x to the 6 plus x to the 4th times 1 gives us x to the 4th plus 2x squared times x squared gives us 2x to the 4th plus 2x squared times 1 will give us 2x squared plus 1 times x squared give us x squared plus 1 times 1, 1. Now, this amounts to x to the 6 plus 3 x to the 4th plus 3 x squared plus 1. Now let's differentiate this. D by dx of this will give us 6x to the 5 plus 4 3s 12 x cubed plus 3 2 6x. Now let's compare it to what we have here. 6x to the 5 plus 12x cubed plus 6x. So you see that it really works, alright? So again, when you differentiate a function of a function, so you differentiate an outside function of an inside function, what you get, what you should do, differentiate the inside function and multiply by differentiate the outside function and treat the inside function as it was one variable, it was a substitution, right? So that's what we had here. We had y is equal to x squared plus 1 cube. We differentiate the inside function x squared plus 1, we get 2x, which is right here, times, if we treat this as one substitution and differentiate it, we get 3 times it squared. So 3 times it, the x squared plus 1, 3 times that squared, times 2x. So that's what we have there. I'll see you in the next video.